Hey everybody, welcome to the Unit 7 Equations and Inequalities Study Guide. First question, define expressions, equations, and inequalities, or explain the similarities and differences between the three items. Expressions are mathematical phrases that contain operations, numbers, and or variables. There's no equal sign or inequality sign with expressions. Equations. This is a mathematical sentence that shows that two expressions are equivalent. It has an equal sign. And inequalities is a mathematical sentence that shows the relationship between the quantities that are not equal. So over here on the right-hand side, the next question for number 2 is give an example of each. So we just talked about each of these. So an example of an expression could be 3x plus 3y minus 7. Doesn't have an equal sign, but I can have numbers, variables, so that's one example. An equation, so going with the similar expression, an equation could look like this. Okay, so we have one side equal to the other side. And finally, an inequality is similar to an equation except that it has more than one solution. So if we have our same expression on each side, this time I'm going to have a less than or equal to sign, meaning there's multiple solutions. Again, equations only have one solution. Expressions have no solutions because we really can't solve them until we find out what the variable is worth. Number 3, circle the values that provide a solution or solutions to the given equation or inequality. So for this type of question, we have to take the inequality and substitute in each of the values here. So we're going to take, we have m minus 7 is less than 13. So now I'm going to take my first number, 10, and I'm going to substitute it in for m. So that's going to be 10 minus 7 is less than 13. 10 minus 7 is 3. Bring down your sign. 3 is less than 13, so that is a true statement. Next one, I'm going to basically rule out 39 because I know that 39 minus 7 is much larger than 13. I don't know about 14, so I'm going to try that one now. So 14 minus 7 is 7. 7 is less than 13. So that's a true statement. And 16 is also going to work. 16 minus 7. 16 minus 7 is 9. 9 is still less than 13, so that's true as well. So we have 3 solutions that fit this problem. The 39 does not fit. Number 4, we have an equation this time, so we're only going to have one of these solutions possible. 4x equals 30 plus 6. So I'm going to do this side first because I'm going to balance I'm going to simplify the expression. 30 plus 6 is equal to 36. And I'm going to bring down the rest of the problem. And I'm going to isolate my variable by dividing by 4. Divide by 4. And then x is equal to 9. I could have also substituted in each of the numbers just to be sure, but if you can solve for the variable, it'll save you some time. For this one, I'm going to solve, again, like I did this one, unlike over here. So 3w plus 2w is 5w is greater than or equal to 30. Again, I'm going to isolate my variable by dividing by 5 because it's multiplying by 5 right now. So divide by 5, divide by 5. 5 divided by 5 cancels out because it's 1 and left with w. W is greater than or equal to 6. So that means looking at my solutions here, I have to find values that are bigger than or equal to 6. So that means that the 6 will work, the 15 will work, and the 30 will work. The 5 will not because 5 is not greater than or equal to 6. So again, I could have used this same strategy over here for this problem, but I wanted to show you both ways. You could have just substituted in to figure it out. This way I think is less work because you're just solving one inequality, and then you're comparing your answers. Solve for the variable, show your work, and don't forget to check your answer. Finally, graph the solution. So for this one, I couldn't copy and paste like I wanted it to, so it's k divided by 7 equals 6 plus 8. So the first thing I have to do is simplify over here to be 14, and that's k over 7. And I'm going to do the inverse. So remember, there's a 1 in front of that k, so the inverse of 1 over 7 is 7. Sorry about going crooked. And then I multiplied this side by 7 as well. And these cancel out, leaving me with just a k. And 14 times 7 is 88. So k equals 88. I would then go back into my problem. Let me get a different color this time. And I'm going to write the problem again. And I'm going to substitute in my answer for k. So k, I said, was 88. And it's supposed to equal 14. So I need to do 88 divided by 7. And that's 2 times. Ooh, looks like I made a mistake somewhere. Oh, I did. Sorry. So that tells me right here that I made a mistake. So I need to erase all of this because this does not equal 14. So it's a good thing I did a check, and that was not intentional, so I apologize. I did my math wrong over here. This should have been 98. Sorry about that. So then over here, this should be 98. And this should be 98. So it should be 7 divided by 98, or 98 divided by 7. It's late, I'm sorry. No excuse though. And then it does equal 14, so this does check out. So it's a good thing I did my check. So k equals 98. Alright, next problem. 9x minus 2x is less than or equal to 19 plus 2. So I'm going to simplify first. So 9x minus 2x, I can subtract those because they are like terms. And 19 plus 2, I can add those because they are like terms. And then I have to isolate my variable. And I'm left with x being less than or equal to 3. So for the check, what you need to basically do is pick a number that's less than 3 and substitute it back in. So I could say 2 and see if that works. If it's true, then I'm good to go. I can also pick a number bigger than that, and if it's not true, then I'm good to go. Next one is 2 plus p plus 4 equals 9 times 2. So I'm going to combine my like terms of 2 and 4 first. So it's going to be 6 plus p equals 18. I need to subtract p from both sides to balance my equation. And that equals p equaling 12. And again, to run the check, I substitute it back into the problem. 2 plus 12 is 14. 14 plus 4 is 18. 9 times 2 is 18. And that checks out. Next one is 24 is greater than 2m times 8. We can multiply here because we don't have to have like terms when multiplying and dividing. So 2m times 8 is 16m. Again, isolate my variable by dividing the opposite. Okay. And then m is less than or equal to, I did my math on the side, and it's going to be 1.5. So again, if I pick a number less than 1.5 and substitute it in, so if I pick 1, 2 times 1 is 2, 2 times 8 is 16. As long as my answer is less than 24, then I'm good to go. Alright, moving on. Oh, sorry, I forgot to graph those. So, let me get a line up here. Double arrow. Oh, I ran out of space, huh? I'll go here, here, here. Okay. So for this problem, the answer was k equals 98, so this is simply going to be, whoa, sorry, that's still on a line. Okay. So this is going to be 98. It's going to be just a solid dot because it's an equation. This one's going to be a solid dot as well, and no line, because it is also an equation. There's only one solution, and make sure you label that point. The next one is x is less than or equal to 3. So since this is a less than or equal to, there's equal to involved, so that's going to be include the data point. So it's going to be 3, and then my data has to be less than that. So my line is going to go this way. Okay? And on the right hand side, on the next problem, I have m is less than 1.5. So this one, the data does not include 1.5. It is an open circle at 1.5, and the data has to be less than that. So again, I go to the left, and then that's those answers. All right, next we have to read the solutions and write an equation or inequality to represent them. So what I've done for this one is Mary Rose has a birthday party in a couple of days, and she wants to make sure each guest has at least 6 candies. How many candies does she need to prepare for 50 guests? So I know that there are 50 guests, and she wants each one to have at least 6 candies. So that means that my number of candies that I don't know has got to be greater than or equal to 50 times 6. So that's going to be 300. And when I graph that, I'm going to get my lines drawn for both problems. Okay. So when I graph that, it's going to be a solid dot because it does include 300. And my line has got to be bigger than that because we need that much or more. Who doesn't like candy, right? We can always have extra. Number 11, Jonah used to ride the bus for M minutes. He moved to a house closer to school, and now his ride is 9 minutes shorter. So he now rides the bus for 9 minutes. So this is not a multiple solution problem, so this is going to be an equation. It says write 2 different equations that represent Jonah's situation. So my first situation was he rode the bus. We don't know how long he rode it, but now it's 9 minutes shorter. So I can take away 9 from the original value, and now he rides 9 minutes. So I can isolate my variable by adding 9 to both sides. That cancels out, so m is going to equal 18. My other equation you could have written, this is the one I prefer. You could have also said 9, simply 9 plus 9 equals m, and that's going to be 18 equals m. But this is the one that I like. So then my graphing the solution is simply going to be 18 because that's the data point. There's no other choices. All right. Next one. John is buying a shirt. His mom told him he can spend no more than $123. How will you represent the price of the shirt? So I'm going to put S because it says shirt, and the price is $123. So mom said no more than, which means he can't spend greater than this. So that means this has got to be the highest price possible, which means the S has to be less than that. But since it says not more than that, we can also include that in our data. So it's going to be less than or equal to for this problem. So I'm going to go to a solid circle because it is including the data point of 123, but the price has to be smaller. Okay, next one. Bobby has a fish tank that can hold no more than 15 fish. He already has 5 goldfish in the tank. How can he represent this as an inequality? So if he has 15 and he can't have more than that, that means that the right-hand side has to be less than this. Sorry, yeah. No, I apologize. Let me fix that. I mean, I said it right, I just wrote it wrong. So this side has to be less than or equal to 15. And he has 5 in there, and he's going to get some more, I believe. So it's 5 plus f. I don't know if you can hear my cat, but she's like running around and making noises right now. So I need to isolate my variable. So 5 minus 5 minus 5, and that's going to be 10. So it's going to be, I can have less than or equal to 10 fish. So it's okay if I want to add 1 more fish or 2 more fish, 3 more, but I cannot add more than 10. It's got to be less than 10. All right. Next one, graph the following inequalities on a number line. Okay, so m plus 7 is less than or equal to less than 10. So I need to subtract 7 from both sides, cancel that out. So m is going to be less than 3. So I have an open circle on 3, and my answer has to be smaller than that. A lot of less thans tonight, right? Okay. H plus 11 is greater than or equal to 20. So I need to take 11 from both sides. That cancels out. Left us with less. H is greater than or equal to 9. So I'm having a solid circle because 9 is included. And my answer can be bigger than 9 also. So I'm going to be going to the right and getting my arrow there. And the last one, in order to make a profit, the student government must sell more than 200 lollipops. So if the lollipops, I'm just going to do X, must be greater than 200 in order for them to make any money. So I'm going to have an open circle on 200 because 200 does not include the data point, but everything bigger than that will make them lots and lots of money to do some really cool things with, I'm sure. Alright, so if you made it this far, nice job. You're supposed to, but I appreciate you doing that. And good luck on your test.